Okay, so let's say that the extension of the second spring is equal to, let's call it delta y. Okay, let's just call it delta y. Now, for the second spring, the force is 2F, so we're going to write 2F here. The stiffness constant is 3K, so we're going to write 3K here. And the extension is delta y. So all you have to do is you have to change the subject to delta y. So delta y equals 2F divided by 3K. Now that you know this, you're going to go back to the first equation. This was the first equation. Because in the options, they want the answer in terms of delta x, you're going to go back to the first equation and you're going to change the subject to delta x. So here delta x equals F divided by K. Now go back to the second equation. Delta y equals 2 over 3 into F over K. And as we know, F over K is the same thing as delta x. It is the same thing as delta x. Hence, we can write delta y as 2 over 3 delta x. So the extension of the second spring equals 2 over 3 delta x. And hence, the correct option is option A, 6A. And you can see that that is the correct option in the marking scheme as well. Okay, then let's move on to question 7. A student drops a ball and measures the time taken for the ball to reach the ground. He repeats this for different heights. He uses a graphical method to determine a value for g, the acceleration of free fall. He plots the height on the y-axis of his graph. Which row of the table is correct for the student's graph? So what is the quantity that he's going to plot on the x-axis, and what is the corresponding gradient of the graph? Okay, first of all, you need to know that question number 7 is about core practical number 1, if I'm not mistaken. Core practical number 1 is exactly this experiment. The experiment that the student is doing in question number 7 is core practical 1. In core practical 1, what did you learn? You learned that we use the equation S equals ut plus half at squared to find g, the acceleration of free fall, or in other words, the acceleration due to gravity. So to find g, you use S equals ut plus half at squared, where S, your displacement, is just your height. It is going to be equal to your height. And A, your acceleration, is just going to be equal to g, which is the acceleration of free fall. Now, the initial velocity in the experiment is going to be 0. Why? Because the student grabs the ball with his hands and then he releases the ball so that the ball falls downwards. In that scenario, the initial velocity of the ball is 0 because it's held in the student's hands. So that's why the initial velocity is going to be 0. That being said, we can cancel out ut because u is 0, so ut is also going to be 0. So what are we left with? We're left with S equals half at squared, right? And S, as we know, is just the height, so we can write h here. And A is just g, so we can write g here, and t squared is just t squared. This is the equation that we use in the experiment. So the student plots h, the height, on the y-axis. What is he going to plot on the x-axis? And what is going to be the gradient of the graph? Now guys, the only correct option here is option number C, clearly. Because when you plot t squared on the x-axis, or time squared on the x-axis, you get a straight line graph. You get a linear graph. And the gradient of this linear graph is going to be half g. What is the reason for this? This question assesses your ability to compare equations with y equals mx plus c. You need to learn how to do this. If we compare this equation with y equals mx plus c, which is the equation for a straight line, we can see that h is just our y. It is on the y-axis, that's why. And our x is t squared, because t squared is on the x-axis. Our plus c is 0, because we don't have a plus c here. We don't have anything being added in this equation. So our plus c is 0. That means that half g is going to be equal to m. And what is m? M is the gradient in a straight line equation. M gives you the gradient of the graph. That's why 1 over 2g equals the gradient of the graph. That's why the correct option is option C. So guys, are all the questions clear so far? As always, if there are any doubts at any point, please feel free to ask. And you can see, okay, question 7, the correct option is option C. Yes, in the Marcus team as well. Let's move on to question 8. The velocity time graph for a train journey is shown. Which of the following expressions gives the distance traveled by the train in time 2t? This is another very easy question. You need to know the properties of velocity time graphs. We know that the area under a velocity time graph equals the displacement or the distance, and the gradient in a velocity time graph equals the acceleration. Here, because we're trying to find the distance traveled by the train, we're going to focus on the area under the graph. So all you have to do here is you have to find out the area under the graph. So you can divide the area under the graph into two shapes. Actually, three shapes. A triangle right here, a square right here, and another square right here. So let's find the area of the triangle. This is going to be half into BH. What is the base? It is just T. And what is the height? It is 2V minus V, which is V. So it is equal to half TV. Let's find the area of the square. What is the height of the square? It's V. And what is the base of the square? It's T. Let's find the area of this square as well. What is the height of the square? It's V. And what is the base? It is 2T minus T, which is just T. So VT. Now we're going to add all of this together. Half TV or VT plus VT plus VT equals, you can use your calculator here, it equals 5 VT over 2. And so the correct option is option D. Yes. The correct option is option D. Let's move on. Question 9. A free body force diagram for an object moving through a fluid is shown. The mass of the object is 5 kilograms. The object is accelerating upwards. It is accelerating upwards at 4 meters per second squared. Which of the following gives the magnitude of the drag force acting in newtons? Guys, you have to remember one very important thing. Whenever you have acceleration, you always have a resultant force. This is the symbol for a resultant force. So whenever an object is accelerating or decelerating, that means that there is a resultant force acting on that object. Okay? Now, what is the formula for the resultant force? You can look at the formula sheet as well. The resultant force equals mass into acceleration. Now here, what is the resultant force equal to? The resultant force is basically the sum of all forces acting on the object. If we take the upwards direction as positive and the downwards direction is negative, then the upthrust is going to be plus 90 newtons, the weight is going to be minus 49 newtons, and the drag is going to be minus D. Let's call it minus D. So what is the sum of all these forces? The resultant force hence equals plus 90, right, minus 49 minus D, and this is equal to 41 minus d. This is equal to 41 minus d. Hence, the resultant force equals 41 minus d, and this also equals mass into acceleration. Guys, what is the mass here? The mass is 5 kilograms, and what is the acceleration? It is plus 4 meters per second squared. Plus meaning positive, so into 4 meters per second squared. So this is equal to 20. Hence, 41 minus d equals 20. Hence, 41 minus 20 equals the drag force. Okay? And so the correct option is option C. Because 90 minus 49 is 41, and minus 5 into 4 is minus 20. So option C is the correct option. Yes. Let's move on to the MCQ, and then we'll do with section B. Okay, question 10. Traffic lights of weight W are suspended from a wire. Guys, also if the mic isn't clear, just let me know. Okay. Traffic lights of weight W are suspended from a wire. The wire is held at an angle theta to the horizontal by two supports as shown. So look at the diagram. We have a traffic light that is suspended by a wire. So the wire is connected at two supports. We have one support on the left, one support on the right. What is the tension in this wire? Okay, what is the tension in this wire? So, look, tension on the right hand side, the tension is going to be acting upwards, and on the left hand side, the tension is going to be acting to the left. The tension is going to be acting to the left, upwards as well. Okay? Now let's say that the total tension on the wire is T. The total tension in the wire is T. This is the total. So on the right hand side, T is going to be divided by 2. Because look, we have one half of the tension going in one direction, and we have the other half of the tension going in the other direction. So on the left hand side, it will be T by 2. On the right hand side, it will also be T by 2. Okay? Now, how do we find T? How do we find the total tension? Well, you have to see, you have to understand that this question is about equilibrium. It is about equilibrium. Guys, what is equilibrium? In physics, an equilibrium system is a system in which all forces are balanced. All forces are balanced. Now, what are the forces acting on in this diagram? Obviously, we have the tension T by 2, T by 2. Then we also have the weight W. So, the weight is downwards and the tension is upwards. The tension must somehow balance the weight to form an equilibrium. The tension must somehow balance the weight to form an equilibrium. So how will the tension balance the weight? To balance the weight, we must look at the vertical component of tension. We must look at the vertical component of tension. We know that we can resolve vectors. So let's take a look at this vector right here. We have tension going here, T by 2. If we resolve this vector into the horizontal and vertical components, this is going to be the vertical component, let's call it V, and this is going to be the horizontal component, let's call it H. Okay? Then, let's look at this vector as well. This is T by 2, this is the vertical component, and this is the horizontal component. This is angle theta, this is angle theta. So guys, because the weight is vertical, it can only be balanced by the vertical components of the tension. It can only be balanced by the vertical components of the tension. So all we have to do, guys, is we have to find the vertical components of tension. So let's do that. For this vector right here, what is the vertical component? It is going to be sine, okay, sine theta equals SOHCAHTOA Toa, so vertical component divided by T by 2. So T by 2 equals V over sine theta, and hence the total tension equals 2V over sine theta. 2V over sine theta. Okay. Oh wait, actually we have, yeah, 2V over sine theta, and wait, okay, sorry, if we change the subject, okay, I think we have to, okay, tension, SOHCAHTOA, yeah, let's change the subject to the vertical component. Vertical component equals T sine theta divided by 2, okay, T sine theta divided by 2. Now we have two vertical components, one vertical component from here, from this vector, and the other vertical component from this vector. So both of these vertical components are equal. Okay, both of these vertical components are equal. So the total vertical components are going to be T sine theta over 2 plus T sine theta over 2. Hence the total vertical component of tension is going to be just T sine theta. Okay? And we know that the total vertical components of the tension are equal to the weight, because it must be balanced. The vertical components must be balanced. Hence, T equals weight over sine theta, because T sine theta equals weight. So T equals over sine theta. Okay, so we don't have that option here. We have W over 2 sine theta. I think we made an error somewhere in the working. I think we don't take T by 2. We simply take T here. We don't write T by 2 here. We simply take T here. Yeah, that's the mistake. I wrote T over 2 for this tension right here and this tension right here, but that's wrong. It's not T over 2. It's actually just T. It's just the total tension. And the reason is because the tension is the same throughout the wire. Yes, that is the reason. That is the mistake that I made. The tension is not T by 2 here. It's not half the tension, the total tension here, and half the total tension here. The tension is constant throughout the wire. So here, this vector is also going to be the total tension T. Here, it's also going to be the total tension T. So when you take T here on both sides, you don't take T by 2, you just take T. Then you get the answer W over 2 sine theta when you do the same working. So that's why option B is the correct option. So yeah, the mistake that I made, I took T over 2, but that's wrong. You don't take T over 2, you simply take T. So option B should be the correct answer, and yes, it is the correct answer. Option B is the correct answer. So that is those are the MCQs, and my thing is that I always do the MCQs in detail. I always do the MCQs in detail. So are these questions clear? Okay. Then let's start with question section B, and then we will end the class after a few questions, one or two questions. Question 11 is, the mass of a car is 1850 kilograms. Some people sit in the car. The car then accelerates at 0.23 meters per second squared, when the resultant force on the car is 460 newtons. What is the total mass of the people in the car? So this is a very easy question as well. So again, it's about the resultant force and acceleration. We know the formula: resultant force equals mass into acceleration. The resultant force here, as I said, is 460, and the acceleration is 0.23. So mass hence equals 460. The total mass equals 460 divided by 0.23. So use your calculator here, and you will get the total mass as, just check. Yeah, you'll get the total mass as 2000 kilograms. Now, the total mass equals, right? The total mass equals the mass of the car plus the mass of the people inside the car. So 1850 plus 150 kilograms equals 2000. Hence, the mass of the people is 150 kilograms. Okay, that is the answer. Is that clear? Okay, then we'll do question 12. A person on skis slides down a slope. The slope is at an angle of 14 degrees to the horizontal. The initial speed of the person is 7.1 meters per second as shown. The resistive forces acting on the person are negligible. What is the speed of the person after moving 15 meters down the slope? Okay, so guys, you have to understand, what is making the person slide down the slope? The thing that is making the person slide down the slope is gravity. If you go to a playground, a children's playground, for whatever reason, and you take a slide, the reason why you're sliding down is because of gravity. Gravity is pulling you downwards. Okay? The same thing happens with the skier. He's sliding down the slope because of gravity. Obviously, he's pushing himself as well, but the main force is gravity. Gravity is causing him to slide down. Now, the thing is, we know the acceleration due to gravity is 9.81 meters per second squared. So you might think that, okay, we know the initial speed, we know the distance, 15 meters, we know the acceleration. We can simply use S equals ut plus half at. Actually, no, we could simply use v squared equals u squared plus 2as to find the final velocity. But this is not exactly correct. You cannot use acceleration as 9.81 meters per second squared here. And what is the reason for that? The reason for that is that this value, 9.81 meters per second squared, is only for the vertical acceleration due to gravity. Whenever we talk about 9.81 meters per second squared, that is always the vertically downwards acceleration due to gravity. Here, the skier is not falling down through the air. He's sliding down a slope. So he's not moving vertically. He is moving at a slope. So what we have to do is, we have to find out the acceleration due to gravity of the skier in line with his movement. We have to find out the acceleration that goes in this direction, in line with his movement. How do we do this? Well, we simply resolve the vector. We know that this is the vector, this is the vertical acceleration due to gravity, 9.81. We can simply resolve this. This would be the horizontal component. And this right here, this hypotenuse of the triangle would be the acceleration that we need. This angle would be 14 degrees. It's given in the question. This angle would be 14 degrees. So to find our acceleration, you simply need to use trigonometry. That's all you have to do. So sine 14 equals SOHCAHTOA 9.81 divided by A. Hence A equals 9.81 divided by sine 14. So V squared is going to equal U squared, which is 7.1 squared, plus 2 into 9.81 divided by sine 14 into the displacement or distance, which is 15 meters. And to find the final velocity, you simply take the square root. of, what do you get from here? You take the square root of this, use your calculator and find out the answer. So your answer should be, about, yes, 11 meters per second. Let's look at the mark to see. Yeah, 150 is correct for the first one. And for question 12, 11 is correct, yes. So that is the correct answer. Is that clear? Okay. Can we do question 13, our final question? Okay, let's do 13, our final question, and then we'll end the class. Okay. An escape lane can stop cars or trucks safely if the brakes stop working when moving downhill. The photograph shows an escape lane. The escape lane is made of sand and is horizontal as shown below. Okay. The resistive force of the sand on a vehicle reduces the kinetic energy of the vehicle. As a truck enters the escape lane, the kinetic energy of the truck is 8 into 10 to the power 6 joules. The sand exerts an average resistive force of 3.5 into 10 to the power 5 newtons on the truck as the truck comes to rest. What is the distance moved by the truck on the escape lane? So how do we find the distance that the truck moves on the escape lane before it comes to rest? Before it comes to rest. How do we do that? How do we do that? We are going to use the concept of work done. What is work done equal to? Work done, or basically energy transferred. Work done is the same thing as energy transferred. Work done equals force into the distance moved. Now here, what is the work done, guys? The work done, what we're referring to the work here, is the work done by the resistive force of the sand. The sand is doing work on the truck. The sand is the thing that is slowing down the truck. So the sand is doing work on the truck to slow it down. Okay? Now how much work is being done? The amount of work that is being done equals 8 into 10 to the power 6 joules. Why? Because 8 into 10 to the power 6 joules is the kinetic energy of the truck when it enters the sand, when it enters the escape lane. The work done by the sand is basically the resistive force taking away this kinetic energy, right? Taking away this kinetic energy. And when the resistive force takes away all of the kinetic energy of the truck, that's when the truck comes to a stop. So using the equation work done, where work done equals 8 into 10 to the power 6, and that is when all of the kinetic energy has been lost, it has been taken by the sand, by the resistive force. At this moment, the force is going to be obviously 3.5 into 10 to the power 5 newtons, and the distance is what we have to find. Hence, the distance d equals 8 into 10 to the power 6 divided by 3.5 into 10 to the power 5. Use your calculator. What do you get? You should get 22.9 meters. That should be your answer. Let's move on to question B. The resistive force exerted by the sand on a vehicle is proportional to the weight of the vehicle. The weight of a car is less than the weight of a truck. Explain how the deceleration of a car on the escape lane would compare with the deceleration of a truck. Now, what do you think of this? Do you have an idea of the answer maybe? Okay. So so let's think about this. Let's think about this. We know that, look, the weight of an object equals its mass multiplied with the gravitational field strength. Weight equals m to g, right? And we also know that F equals ma, right? Where F is the resistive force, basically. F is a resistive force, and this equals the mass of the car or the truck, and A, which is the acceleration of the car or the truck. In this case, acceleration is deceleration because the car or the truck is going to slow down. So, F equals ma and W equals mg. The thing is, right, that mg is directly proportional to ma. mg is directly proportional to ma. Why? Because the more, if ma increases, right, and ma equals a resistive force, the more ma you have, the more resistive force you have. And the more resistive force you have, the more work done is a resistive force, the more work done the resistive force is going to do. Okay? So with more resistive force, there's going to be more work done. Okay? At the same time though, you're going to have more mass. And when you have more mass, you have more kinetic energy. So all of it balances out. All of it balances out. And so the deceleration of the truck and the car is the same. So let me explain again. Look, weight equals mg, F equals ma. Mg is proportional to ma because the more ma you have, the more resistive force you have. And the more resistive force you have, the more work done the resistive force is going to do. At the same time, you're also going to have more mass. So there's going to be more kinetic energy. So the resistive force is going to have to do more work to remove that kinetic energy. So because of this, even if you have more of a resistive force, you're also going to have more kinetic energy. That's why the deceleration of the two is going to be the same. The deceleration of the two is going to be the same. So that is the answer. Let's look at the marking scheme. For the first part, the answer is 22.9, which is what we got. And for the second part, it is weight equals mg, F equals ma, so mg equals proportional to ma. Resistive for, okay, deceleration of the car is the same as that of the truck, which is correct. So are all these questions clear? Okay. Okay, that is going to be the end of today's demo class. Please just message me for more details if you are interested. And